Okay, so this is one of the easier section 5.4 problems. So let's start out with what we are given. It tells us that we have two cars traveling at 27 meters per second. It also tells us that they are on a curve of radius 120 meters. We also know that one of the cars has a mass of 1,100 kilograms and the other a mass of 1,600 kilograms. Now we know that we need to find the centripetal acceleration for each car. And we know the formula for centripetal acceleration is AC equals V squared over R. So since we are given both the velocity and radius, we can simply plug in and solve. So now we have 27 squared divided by 120, which equals about 6.1 meters per second squared. And this will be the centripetal acceleration for both cars, even though they have different masses. That is because the mass of an object has no effect on its centripetal acceleration. Look at it this way. The Earth orbiting around the Sun versus a feather orbiting around the Sun on the same path. Both of these objects must have similar velocities in order to stay in orbit, but their masses are irrelevant. Now that we have plugged in our numbers to find the centripetal acceleration, we need to find the centripetal force for each car. The easiest way to find the centripetal force would be using the formula Fc equals MAC. Since we already have the centripetal acceleration for each car, all we have to do is plug in the mass and the centripetal acceleration. So now we have 1,100 kilograms times 6.1, which will give us about 6,710 newtons. Now we need to do this for the other car. So 1,600 times 6.1, which will give us 9,760 newtons. So now that we have the centripetal acceleration is equal to 6.1 meters per second, and this centripetal force for one car, and the centripetal force for one car being 6,710 newtons, and the centripetal force for the second car being 9,760 newtons. And that is how you solve problem number 54.